right, hello, Kagglers. I just want to let you know this video is not live. I have recorded this ahead of time, so if you, I don't think you can leave comments live, but if you're wondering what's different, that's what's different. So I'm going to be jumping back into my TPOT model here. So TPOT is an automated machine learning tool, and I am interested in building a model that will predict job title given the role that you're trying to fill, and taking this information from the Kaggle Data Science Survey in 2018. So if you know, for example, the tools that you want somebody to be able to use, and the cloud services, and the programming languages, and the compensation, and the required degree, and all of that, then you can use the information on job titles that Kagglers already have in order to guess what the job title should be. So it's going to be a multi-class classification problem. Let's hop back in, edit. So last time we got, did I not click good? Last time we got started on doing the, little bit of the data cleaning. So TPOT, I believe, requires numeric features. So we're taking all of our categorical features and deciding what sort of encoding we want to do with them. And we went through and did that by hand, deciding which features we wanted and whether we wanted categorical encoding or one-hot encoding. And the difference for those, let's run this guy. And the difference for these is that one-hot would be that there's a number of categories and you can have multiple categories. And then label encoders are going to be each label is going to be assigned to a number. So I said that label encoders would make sense for things where there is like a less more relationship between things, and that one-hot encoders would make more sense for things where you may want multiples of them, for example. So we have gone through and decided what columns we want to include, and now we need to actually do our encoding. Let's get started on that. Q6 is going to be our Y. It's going to be the thing we're predicting. It's the job title. And I think it makes sense to... sorry, I shouldn't make weird sounds in the microphone. I think it makes sense to look at the... what's in there? I think I can do Q6 dot... Nope, got to be capital Q, though. Value counts? Yeah, I think that'll work. Let's find out. Yeah, okay, excellent. So the titles that we have here are, you can see there's quite a bit of them. There's a lot of, let's see, it looks like we've got about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's a lot of chief officers. So we have about 20 classes, which I think is a little much. 117 developer advocates. It's a pretty good sample. I think I want to pick the ones that have more than 500 individuals in it, and I think we should get rid of not employed, other, and student, because those aren't job titles you'd be hiring for. So let's start by doing that. Get only very common titles and drop specifically student and other and what's the last one? Not employed? Not employed. Because you don't want to predict the job title not employed. You're not going to be advertising, hey, I want a not employed, must have PhD and 10 years of experience with TensorFlow or something. Oh, somebody's running a siren. And I don't remember how to, what's that? So it'd be Pandas drop rows based on column value. I think column, can I actually say, is less than 1,000. So I'm trying to figure out a way to quickly drop rows with less than, oh, we said 500, right? with less than 500 examples. I don't think this is going to work. Hey, what do you know? It did not work. Unalignable Boolean series provided as indexer. Okay, so first thing we need to do is get a list. Let's actually on column value count. I'm just going to search for this rather than trying to figure it out myself, because I'm very positive somebody else has probably done the same thing. Conditions on column values. That's the exact thing that I'm looking for. Thank you, internet. Blah, 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 blah. Okay, so we can do it just by listing the names. No, okay, so this is creating a data frame object. Okay, so you need to get the index names and then use the index names to drop things. That seems fine. All right, so the index names here, and then in our data frame, we have our data frame where Q6, question 6, what is your job title? I don't think this is going to work. Is greater than 500. And then data frame is what we called our data frame. Boolean series key will be re-indexed to match your data frame. All right. Unalignable Boolean series provided as indexer. Index of the Boolean series and the indexed object do not match. Oh, it's hopping out there, huh? All right, so the problem is here that value counts is not the same dimension as our data frame. So, what we need to do first is get just a list of the names. Oh, not a markdown cell. If it were code, that would work better, huh? Okay. Let's call this popular titles. Popular. Yep. Popular titles getting more than 500, and then from there, what we want to do is get just the names. Can I use a Boolean index here? Yeah, there we go. Excellent. All right, so then I'm going to rename popular titles this. If this was R, I'd write a pipe, but pipes and pandas are a little bit fussy to set up. Is there any way to do in? Like match any? How would I phrase that question? Python pandas true if match in popular titles. That's for the best dog at the dog show. I think this is a data frame. Is that an argument? It ain't. What are an argument? Are the names the indexes? It is. Okay, excellent. Index. All right, let's try that one and see how that gets us. Get the index of rows or columns matches data frame dot is in. Okay. whether each element of the data frame contains the values. All right. Data frame dot is in 0, 2. Okay, so we should be able to, in theory, let's try this. Data frame is in, and instead of 0, 2, we should be able to do popular titles. False, 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 false. And actually, probably we do actually specifically want question 6. We don't want the whole data frame. I think we've messed up. I think something is wrong here. Okay, so what does this need? This needs a list. So what we need to do is we need to pandas convert index to list. I think we're passing in the wrong data type, and it's expecting something else, and we're giving it the wrong thing. Index.toList. All right, that sounds like the one that we want. .toList. Yep, 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 all lowercase. All right, that did not work. Only list-like objects are allowed to be passed in you passed in a method. Oh, right. Yeah, nice, 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 nice. Okay, that is what we want. So this is going to give us the index of the rows that have popular titles. Get rid of my little search term there. All right, and then actually I should probably from the popular titles drop specific things. So I think what I'm going to do is I'm going to keep reassigning things to the same name. Comment this out because we don't need it just at the moment. And so now we should be able to, if we see popular titles, we should have a list. Yep, there we go. And then I want to drop from a list. So pandas drop from a list. Nope, Python, this is not pandas. Let's see how that works. Python list remove removes the item which is passed in as an argument. Can I pass in the names? Yes, I can. Excellent. All right, so I should be able to do popular titles dot remove and then be able to pass in the things that I don't want. And what I don't want is not employed. What I don't want is student. Peace out. And not because these are not, you know, valuable, important, and then other, I think we can also just get rid of valuable, important people at different stages in their life journey, but just because these are not job titles that you would look for. So, remove takes exactly one argument, 3 provided. Remove method on list, have duplicate animals. Try to delete an element that doesn't exist. Okay, so I guess we have to do each one individually? Can I pass in a list? Is that gonna work? It would be nice if I could remove, like so. Let's see. Nope. Remove X. X not in list. Alright. I guess I have to do it 3 times? Python remove multiple remove multiple items list, I think is probably going to be the best search term for that. Help me, internet. Remove multiple elements from a list in Python. That's what I want. What? No, shoot, go away. Multiple elements. Example 1. You do a loop. All right. Create a new list. Create a list. Remove adjacent elements using slicing. I don't think that's going to work for us. Remove list comprehension. So this is probably going to be the best thing that we want to do. So let's take a look at that. So we've got our list, and then we have our little... Okay, so that looks like actually a dictionary of things that we want to remove. So, whoop, there we go. And and then popular titles, element for element in list, if element not in, unwanted num. Let's call this unwanted num for now. And I'm going to call this popular titles 1 just for my, all right, we didn't get any errors. Let's make sure that we get what we want out. Yep, that looks good. All right, so we have 1, 2, 3, 4, 5, 6, 9-way classification, and we have, I think, a fairly shape, I think. Yeah, and we still have a fairly big data set. We have about 23,000 classes. And we have at least 500 examples of each of these classes. So I feel pretty good about being able to solve this. This feels fairly tractable to me. All right, so let us. All right, so we have our list comprehension, and I feel good taking this and adding this to my little area here, and let's call this unwanted titles actually, and then make sure that I change it in both places, and then calling this popular titles. Excellent, and then dataframe.q6, that is in, and then popular titles. So we should be able to use this to filter our data frame. So let's make sure, why are we doing this? Only count, only use most popular titles, and then remove job titles you wouldn't advertise for. Excellent, and then what happened? What did I do? Did I move it? Where'd it go? I think I just I think I moved the thing. Okay, so now we have give the names of intersects of 30. Okay, gotcha. So now we can add this bit where we actually do the dropping. So we can do this. This requires a Boolean, so we can use it like so, and then get the index of the Booleans, and then get rid of you, and then actually drop the drop less popular titles, and then remove those, and this will get us the data frame out. It won't actually save the data frame anywhere, I think. Does drop work in place? Did we lose some dimensions? Yeah, okay, so we have about 1,000 classes. We have about 1,000 examples across, what was it, 9 classes? So there's a little bit of imbalance there, but I feel okay with that. It still sounds doable. And because it's multi-class classification, we'll probably have like a probability of each job title, so it should be a helpful first step, even if it's not ideal. And maybe we'll have even more respondents for the current survey, which is still underway. So if you would like to participate, you are more than welcome to. Please do. All right, excellent. So here we've got only the most popular titles. We've started our data cleaning. And let's actually move this whole cell up a bit. So we read it in, we do our cleaning, and then from here, so we've done our the cleaning that we need for our what's this called? Target variable. But what about the variables that we are using? And this will create more variables than we have currently. It will drop some of them, and some of them it will make one variable per instance. So things that we want to drop, I do not wish to share my compensation. So after all of this cleaning, we're probably going to end up with fewer rows and more columns, which is going to make our job a little bit more difficult, but hopefully still doable. And if nothing else, I think we can probably augment this data with the data from 2017 as well if we did need more. All right, let's see. What were we doing now? Let's just run the cell. I still need all this information. Code. So I do want to drop, let's see. That's one, and it's Q9. Isn't. I do not. Okay, let's quickly. What is this? df dot Q9 dot value counts, just to see what's in there real quick. I do not wish to disclose my approximately Alright. Actually, I think I only want the numeric ones. So ones with numbers in them. Python filter rows if have number. Ideally, I can get somebody's regex that already works and is good to go, and I can just use it. How to filter data from columns, subset based on column, filter rows by column value, pandas dot filter. Oh, just like R. All right. I think this is gonna work actually really fantastically. All right, and then the regex that we want is 0 through 9, and we want at least one, but as many as you like. Oh, right, and it is specifically, it's not the whole data frame, it is specifically, I believe, question 9. All right, and I think I actually don't need to say which axis it is, because it is a series. Well, that sure didn't work, huh? What if I say you have to have 1? Nope, still does not work. So this should be, this is a regular expression that will match any digit from 0 to 9. So it should not match NaN, and it should not match this. I do not wish to disclose my approximate yearly, etc., etc. That should not show up. Maybe if I ask specifically for a comma. Let's see if that works. No, that's empty. Okay. What if I say specifically a 0? Nope, that doesn't work. All right, let's check out this this regex a little bit closer. Select columns by regular expression. $. I don't know what that means. Oh, that the column name has an E in it. Okay, so here we're actually filtering by the gotcha. So here we're actually filtering specifically by the name of the column and not the quality of the data in the column. So the reason that all of these are working is that Joe should still not be working because it's Q9 is the thing, but 9 is definitely a digit, so it was showing up in the first regex. Okay, so actually I can't use filter, unfortunately. So I got to do this weird workaround like we did up here. So I do need to, let's see. If this were an R, I'd be done already. Q6. Pandas filter rows by regular expression. Let's see if we can do that, because I want all of the numbers specifically. I want only the columns that have numbers, because those are the ones that are going to have a useful salary. How to filter rows in Pandas by Regex. That is indeed my exact question. .b.str contains. Fantastic. Starts with might be a little bit faster because you don't actually need to look at the whole thing, but I could be wrong about that. Q6.string contains, and specifically we want at least one digit. So between 0 and 9. And let's just comment these out real quick. What if I did starts with instead? That might be better. Why are these all false? These should not all be false. Because if you look at these, is there space ahead of it? It looks like all of them are going to contain at least 1 0. So let's try contains, and then we look for at least 1 0. This is going to be a little bit brittle. So this might be not the best option long term. Are those not z? I see a 0. I spy with my little eye a 0. Let's see, 23855, 23855, false. Okay. It should be true. It should be true that it contains a 0, one of these guys, one of these guys, but it looks like it is not. Oh, do I need to say regex equals true and NA equals false? All right, so maybe I'm just missing some options. Let's give that a little try. Nah, that doesn't work. So the nice thing is that it has set all of our, well, that's a weird spacing. It has set all of our NAs to false, which is good. But it has not set things where that is true to true, and I don't know why. No, I'm just thinking. Let's try that. So we're going to look at the first index, and we want it to be a number. Now, actually, I think we can do -1 to get the last one, and it should be a 0. Let's see. Because for the ones that are numerics, the last one is a 0. Nope, don't work. That does not work either. Because you can see here the last item is a 0, and that isn't working. It's the wrong question. Solved it. All right. Okay, so the problem was that I was looking at question 9, which has question 6, which has no numbers, and not question 9, which does have numbers. Hashtag dyslexia. Okay, so we have our... So we're going to look at our data frame, we're going to look at this, and then we're going to take that as the index. Index, and then we're going to... let's call this index names, because that's what it's called here. And then in place is true. Oh, remember when I started earlier? Is it happening in place? Yes, I have passed in an argument so that it will do so. Oh, should probably use variable assignment, huh? So now if we look at shape, it should be even smaller because we've gotten rid of... so now we're down to 5,000 for 9 classes. So it is getting a little bit smaller. That's okay. So remove rows without salary info. Because you want to know what the salary is going to be when you are advertising for a job. All right. I'm just going to lose a little clean titles / target variable, and then clean and transform input variables. Okay, so we have our target variables and our input variables, and we want to make sure that those are both good to go. And I think we are good here. So that was comp, and so we've done that one. And the rest of them I think should be good to go. Question 11, all parts to on hot, drop other text. So from here we need to select just the columns that we're interested in. So here we can use filter actually. So dataFrame filter, and specifically we are looking for it needed to be in a dictionary, right? So Q6 we want, Q6 we want, Q4 we want, Q7 we want, Q8 we want. Oh goodness. Q9 we want. I can see that these are not consistent. I'll fix it. Q9 we do want, Q10 we do want, Q11 we do want, Q12 we want, 15, 16, and 19. And Q19. And I'm just going to put stars after some of these. Sorry, dot star after some of these, so that it will match all of the ones that are sort of similar. Because there's quite a few questions where they have the question, and then each possible answer for the question is its own column already, and I want to make sure we get all of the columns for the questions that we are interested in. Variables. Variables, I'm going to call this, and I want to split it across multiple rows because I don't want the PEP8 sticklers to be angry at me. Filter, and then all variables, and then we do want to make sure that these are in the right order, so we're not calling something before we create it, and it's definitely not going to work. Oh. Okay, it actually looks like it worked okay. Great. Did it? It did not. Okay. So it looks like the and all related ones are not working as intended. So we have 4, 9, 7, 6, 8, 10. Do we have 11? We don't have 11. We don't have 12. We don't have 15. We don't have 16. And we don't have 19. Okay. Filter, is there an option here where I can just say only the ones that starts with? Actually, I think Regex will work because it doesn't have to match exactly. Let's actually look at the, what is this, the Pandas filter function. Let's look at the documentation real quick and see if we can get some more helpful information. Okay, so I think I can do like, maybe? Except it wants a string. Okay, so I want to, what do I want to do? Pandas filter like list of columns. Because I want ones that are like the ones in my list, not that are exactly the same as the ones in my list. Use list of values to select rows, filter data. If value in common is a filter. Values common, filter subset, does not filter data frame on its contents, applied to the labels of the index. These items, like and regex parameters, are enforced to be mutually exclusive. Okay, so I can't do both. Noted. All right, I gotta wrap this up soon. It's not gonna be a full hour, unfortunately, because I got other stuff. Let me double check my calendar. So it works for some of them. It works up to Q10, right? 6, 4. I don't know why they are being returned in this order. That is very weird to me, because they're not being returned in alphabetical order or the order that they show up in the data frame itself, or the order that I was passed into the filter by. So there must be something behind the scenes that's going on to make the whole thing a little bit more efficient, would be my guess. I mean, we could just, like, for now, just go with this. Data frame subsample. So just work with this for just a little bit to see if we can get it to work. So this does not include tooling info. So we don't have as many features, and we're probably not going to get quite as good of a result, but it might work nonetheless. So all the questions we'd like to use, Q10 plus are multi-part and not included in filter. All right. So we can cross that bridge when we come to it. I mean, technically we're at the bridge now and I'm just ignoring it, but we're going to ignore that for now. So I have a little subsample here, and I've got my subsample, fantastic. And then if we do df.subsample.value counts, I should have an array? What? Is this not a data frame? It's gonna be a big one. I probably shouldn't have printed this out, but oh well. No, okay, yeah, no, it's definitely a data frame. I don't know. Oh, I think I need to say shape. I don't think I can do value counts except on a series. Okay, so we got about 5,000 items. And from here, what were we left with? We were left with current compensation, highest level of education, industry, years of experience, and how do they incorporate machine learning. So for the moment, let's just get all the way back down to here. category encoders. Let's just use the category encoders, and let's use I don't have a strong preference here. Let's see. Tell me about Target Encoder. Features replaced with a blend of posterior probabilities of the target given a particular categorical value and the prior probability of the target over all of the training data. For the case of continuous target, features are replaced with a blend of the expected value of the target given particular categorical value and expected value of the target over all of the training value. Yeah, let's use target encoding. Why not? So what this will do is it will take our features and it will normalize for basically class imbalances a little bit. What's Helmert encoding? Contrast encoding for encoding categorical features. Oh, this might also work for us as well. What's the output look like? They're not going to tell us. It's a mystery. Okay, noted. This might also work for our specific use case. Let's see, what does their very simple one say? Import category is CE, encoder.fit. Okay, so we can pass which columns we are interested in doing each method to into this method. And it looks like this might be... what did we say we were going to do? We were going to do the target encoder. And let's just... Can we pass it for all of our encoders? All right, so let's do a little bit of x equals df dot subsample dot drop, and then q6 because that is our target variable, and then y equals df underscore subsample dot q6, that is our target. Okay. So I don't think this will work. Let's see. If we just remove the columns, I think we're going to get an error because it wants to be passed specific columns in. Label Q6 is not contained in access. That work? Okay, so where are we getting the new axis, axis.drop? Oh, right. I think I'm dropping along the wrong axis. I think it needs to be axis equals 1, I think. Let's see. So the problem is in me, must be string, not int. Transform object array, ensure numeric, return delegate. So where am I getting this? I'm getting this in encoder fit. During handling of the above exception, another exception occurs. Must be string, not int. I see, and I don't think it will automatically pick one for us. Let's see, what are my options? Leave one out encoder, one hot encoder. Well, let's try one hot because that should work with string as well. Next, name x30 is not defined. Data frame subsample is what x30 is. Unexpected input dimension 6, expected 5. Oh, right. If we look at x cleaned, all right, no, so everything has been one hot encoded. So what rows do we actually want to do one hot encoding for? So we have 4, 7, 8, 9, and 10. So one hot encoder, we wanted to do calls equals, and we wanted Q7 specifically, and then, I I'm assuming I can do multiple things in one encoder, otherwise they have used a code example that makes no sense. And then for the other ones, I wanted to do label encoder, level edge education, and then do read which business uses ML. And I guess we can try target encoder for that. That should work. Famous last words. And the calls for that one, the columns we wanted to do that to specifically are Q4 and Q10. Error, problem. Must be string, not int. Must be string, not int. All right. Is there a problem with df.q4 maybe? df subsample.q4. Okay, so I think the problem is NaN is being treated as a numeric. So I think wherever we see NaN, we should probably treat it as no, as none. Although that's a decision that will have downstream ramifications. Oh, let's try a different encoder, because it's definitely the target encoder that is doing that. So let's try ordinal encoder, because those also both have an ordinal ordering to them. So now we should have, yeah, excellent. So now we have ordinal encoding for Q4 and Q10. And actually we probably want ordinal coding for Q8 as well. And ordinal just means it's ordered. Q8. Now if we look at xcleaned, yep, fantastic. Okay, so we're seeing all of these things, and then I think I did this backwards. I think I did the Q9 filtering backwards. So let's go back up and do it not backwards. Yeah, no, I'm dropping those indexes. I don't actually want to drop those indexes. So what would that be? Pandas drop not in index. Glad we figured that out, huh? Label, if any of the labels not found, reset index, drop by index. Pandas flip Boolean list, I think it's a list. Hopefully that will take all the trues and make them false, and all the falses and make them trues, etc. Element-wise, logical not. That is what I'm looking for. How do we do it? To invert a Boolean series, use the squiggle. Or negative. All right, so let's do that one. Oh wait, that's not going to work either, because that's the one that we need to negate, because that one's the Boolean index. So I think that should work. Filter, okay. And that should work. And now here we should see that Q10 should be, it is empty. All right, I messed up. Okay. Maybe it is this that can go. No, that's the index names. So we have this logical string. Okay, let's take a peek. It's empty. All right. That's empty. That's empty. All right, so at some point we've dropped everything. Let's try reading it in again, see if that helps. Oh, okay, because we've already done the dropping. None of them contain 0. And if I... Yes, okay, so this is the one that I should reverse. So I should rerun all of this, and this will hopefully get me... now this should all be... Yeah, okay, this is all first false because I'm reversing it. Okay, excellent. I think I fixed it. And then... Boop. Boop. I should have all numeric here. Yes, fantastic. And then Q7, I can probably do... it's not ordinal. That one I can probably do target for. So let's try that. Oh, where was I? Category encoders here. So I can probably do, not ordinal. I can probably try target encoding there because that should all be strings. But let's find out. I will say, I haven't worked with this CE class before. It is pretty helpful. And specifically, this one is Q7. You've categorical data, but your model needs something numeric. Right. Okay, so only one of these is being in... Okay, so, all right. I thought that this encoder object could do multiple types of encoding at once, and as it turns out, it cannot. So that's not super helpful. That's actually much less helpful than I thought it was. All right, noted. Okay, so we need to do this, and then we need to do a second encoder, and then... yeah, do the whole thing again, except instead of X, we have X cleaned here. And that should work, hopefully, that we have, yeah, excellent. So you can see we have numeric ones here, and then we have one hot here, and this one is just numeric. So that should be helpful. And now, hopefully, we will be able to look at that. All right, so X cleaned is what our data set is called now. So hopefully we should now be able to feed it into TPOT. All right, so our data is going to be X cleaned. Our target is going to be Y, because we already did this a little bit earlier. I'm okay. We could probably actually go up to 80-20 for test train split. Let's try that. Okay, so that's worked, and you can see we have about 4,000 training cases and about 1,000 testing cases. And here we should be able to just let it run, let it think. And that'll take a minute, especially because the data set that we tried the first time, the iris data set, is much smaller than this guy. Big stretch. Okay, so lots of work left to do, but it looks like we've finally got at least part of it working, and then we can spend a little bit more time sitting down and working it through. Also, I checked my next meeting isn't for a while, so if you're worried about when I'm gonna do casting roll safe. So I'm assuming that we had to do this by hand. Maybe I was wrong. This one, and then Y is df subsample dot q6. Will that work? Okay, that works. I didn't expect that not to work. This is what I'm interested in. Noted. All right. Randomly collect a subsample of training data for the pipeline optimization problem. is NaN is not supported for the input types, and the inputs cannot be safely coerced to any supported types according to the casting rule safe. Okay, so yes, I think that's not going to work. I think I need to undo this. And I think I do need to... and I think I do need to make sure that my salary column is numeric. So I think that one is probably ordinal as well. We can probably get away with just doing that. And that was Q9, right? What if we did these in order so that it was good to read with our eyes and not bad to read with our eyes? Q9, there we go. Run that. Run that. Nope, shoo. And now hopefully we won't get that is NaN error because all of our input should be numeric. Hey, and it working. So it's going to take about 450 generations, and the guess is about 20 minutes. And I don't got 20 minutes to just like chill and hang with you guys, especially A, because you're not live, and B, because I do have other things to do. So I'm going to call that here. I'll report back about what the results were. But we did get fairly far today. We did encoding, and I found out that this categorical encoder can only do one type of encoding at a time, despite the fact that you were specifying which columns you need it to do. So that's frustrating. And then we have our data cleaning that we've done. So a data cleaning episode, getting ready. But the nice thing is that now that I've kicked it off, this should just continue to train on its own. So it's nice. All right. Thank you for joining me, everybody. I hope you have a great weekend, and I will see you on Kaggle. Bye.